So in the assignment, the work or the thing that you want to do is basically write this portion, which is basically converting, or we can, I can broadly say that you need to write this entire process in your program, where I will be giving you a raw document and it will be producing me with an inverted index. And what is the utility of an inverted index? We know, I hope we have understood by now that using this inverted index, we will be able to perform this search pretty quickly and pretty efficiently as well. So broadly, an information retrieval process can be broken up into two parts. First is indexing and second is retrieval or search. Although there is another portion or another process that is associated with the information retrieval process, that is basically the feedback. Like using this information from the user, which documents are relevant, which documents are non-relevant, using that marked document to actually train or actually build a feedback system. This feedback system is another part which we will be discussing in details in the second half of this course. For the time being, we have discussed this part, and I hope you have although we will be discussing this, but I am sure that you know what this search is all about. It's the process that we do in every day, in every day of whenever we are performing a Google search. So given a query, using some retrieval model, specifically we use Google most of the time, we want a set of documents which are basically relevant to our query or our keyword query. Now, as in the assignment problem that I have given, you need to make an inverted index. It will be, I totally understand, and I hope you also realize that the program that you will be writing will not be making a very efficient inverted index. It will be just working on a toy collection like the one that I have provided, having the size is 78 MB or around 80 MB. But as I said, real life collection can be of size in the range of say 100 GB or more, right? So the program that we will be writing will not be an efficient one. It is, it is totally understandable that it will not be an efficient one which will be able to handle a large data set of this amount of size. Okay. So given so by this, this searching scenario is pretty common, right? So there will be so many different collections, right? Say C1, C2, there will be different collection with different modalities, and also different sizes. Those are basically available in the research domain. And for them, let's consider the primary operation that should be applied on those data sets, on those collections, are basically this searching. Then we need an efficient algorithm or efficient tool. Tool should be the right word here. We should be having an efficient tool using which we can make this inverted index quickly without spending much time on writing a program on our own, right? We need some tools which will be doing that to us just out of the box. Given collection, if we if we have a collection and if we want to make an inverted index with that collection, using that tool, we'll be able to do that with less effort. So one of the major tools such as of such categories is called Lucene. It is a Java-based information retrieval engine which is responsible for making this indexing given a collection of documents, and which will be able to help us with searching in that index as well. So basically in Lucene, so this part will be taken care of by the Lucene. So basically, given the raw document, it will be indexing, it will be making the index, and given a query, it will also be helping us with searching the index for certain documents. So very broadly, I can say this is the retrieval system's responsibility, this box that I am drawing. Also, the feedback model can also be a part of that retrieval system. And one such retrieval system is called Lucene. Now, based on Lucene, there are many popular search engines like Elasticsearch, Solr, and so on and so forth. There are so many. Just to name you some applications where Elasticsearch is actually used, are the very popular web portals or web domains such as Netflix or say Amazon. They actually use this Elasticsearch and sometimes this Lucene to perform the search, right? So considering so basically another, just a history is Lucene was built somewhere near in the early 20s. So I think it was developed in 2001. So it was developed from the point of view of being applied in the actual industrial applications. And from them, Lucene was the main core, which is basically containing all these libraries which can be used to perform those two operations, indexing and searching, right? And using those libraries, these are certain sub packages, or you can say sub applications, which are specific to certain domain in which they are applied. So in the background of all these applications such as Elasticsearch, Solr, Tika or Notch, Lucene is running to perform the search. Now in this course, we'll be using or we'll be talking about the core thing or the core library, which is basically the Lucene. Note that Lucene is written in Java. Now certain features of Lucene. So Lucene is kind of built considering the broader aspects of search. So there are certain limitations of Lucene as well. Let me start with giving you the limitations of Lucene as a feature. So there is actually no support for synonyms while searching in Lucene. So if I search with the term say car pollution, and in the document there is the term called vehicle which is present, then there is no way using Lucene we will be able to do this overlap. It is completely based on term overlap, the basics of the information retrieval. So there is no such support by the Lucene. Once you index a document, there is no way you can actually update the content of that document. And another major drawback or limitation of Lucene is there is no built-in support for parsing any particular document. So as we have discussed, this corpus can be containing documents in any category, any types, say .txt or say .doc or say .pdf or say any other document, other text document, right? If the ultimate target for which we want to build a system is search, using Lucene there is no built-in support to accommodate this kind of different categories of files. It only considers a stream. Now it is the programmer's responsibility, that is, it is our responsibility to make a stream from this document or this PDF document or this .doc document or this .txt document or any other text file. So as a result, this Lucene cannot be used just out of the box. I guess this term is, or this phrase is new to some of you. So by out of the box, we used to refer to the concept that this Lucene cannot be just applied on certain applications. We need to write something to make it compatible with that collection or that type, then only we will be able to apply Lucene. That is the meaning of out of the box. So given a collection, say containing a set of doc files, .doc files, straightforward we will not be able to apply Lucene. We need to write a program on our own which will be converting this doc file to basically a set of stream or a stream of data. Then only we will be able to use Lucene for our purposes. This is in fact a blessing in disguise. Why? Because in that case, the flexibility is on us, is at our hand. We can actually write any type of application based on our data. So as I have started today's discussion, we should be considering ourselves as scientists, or at least not scientists, but at least researcher or programmer. You can consider yourself as a computer programmer. Now, from the programmer's point of view, it is our responsibility to actually write the necessary information or necessary programs that will be actually making our life easier. Because I guess you have very less exposure to programming till so far. So far in your academic career, but I hope you have realized that understanding a program written by other is a very tough job. Considering a program of say containing say 100 or more than that, more than 100 lines, it's always easier to write the program on our own rather than to understand others' program. So that's why this is actually a blessing in disguise. So the responsibility of us, the programmers, will be to write the wrapper or write the parser for this kind of a document. or any other type of text document that we want to index, right? So these are the features which you can refer to as the limitation of Lucene. Together with that, let me give you the positive features as well. Positive feature is Lucene is very simple. I mean, if you start learning the Lucene's inbuilt function, you will be able to understand it is very it is written in a very simple API format. And the reason for which it is very much applicable by many real life industries is because it is very fast. So you can understand that, I mean, Amazon, the primary operation that we perform is basically search. We search for an item, or in Netflix, we search for certain movie. Also, if you have a Netflix account, or if you have access to a Netflix account, you can try searching with certain, say, dialogues of a movie in the search bar. Most of the time it will be giving you the movie in which that dialogue is actually occurring. Basically, while indexing the movie together with the video file or video stream, it is also indexing the subtitle. And whenever you are performing a search on certain dialogues that was stated in the movie, it is basically being searched in this subtitle field in Netflix. That's why we are expected to get the movie which is containing that say the catchphrase. And other features are, using Lucene we can actually perform a concurrent indexing as well as searching. So together with indexing, we can also perform searching in the same index, which will be a little bit tricky, but it can be actually done. And another very important feature is it is free. So we can download it on our own, and as it is open source, we can change it as well. If we see a bug in the code, we can actually fix the bug, and we can put a pull request in the GitHub repository of Lucene. It is a huge community. As it is open source, even you can also participate in building the Lucene. And another very important feature of Lucene is there are multiple implemented retrieval models which are available in Lucene. The one that I think I have mentioned the name is called BM25, which was built in earlier, again 2000 or late 90s. It is still one of the most robust retrieval model. Together with that, there are around 6 or 7 different retrieval models that are already written inside Lucene, which we can use. So if you want to do some information retrieval research using Lucene, these are certain GitHub repository from where you can actually start with. Now let me give you a very basic background of information retrieval research domain and where this Lucene is coming into the picture. Now, as we have said, the research on information retrieval was started by Gerard Shelton in late 60s. Okay, so he was the co-founder of the computer science department at Cornell University as well. When Gerard was working in Cornell, he started developing a retrieval model called SMART, which was written in C. So together with Gerard and his team, he developed the first retrieval engine known in information retrieval engine around the globe in the late 1960s. Then it actually, it was actually very popular till the 90s, early 90s. Then another group from University of Massachusetts at Amherst, together with some colleagues from Carnegie Mellon University, they started developing another retrieval model, which was called INRI. Now note that when SMART was developed, then there was, I think Larry Page was not even born at that time, the founder of Google. So at that moment, Gerard Shelton developed a SMART, which is basically a retrieval system. Then still, when INRI was developed, Google started, but that was actually not that much popular or that much robust as it is now. So it was written in C++. It was developed in late 90s. Then from INRI, another Java counterpart was developed by the same collaboration of UMass and CMU, which was called Galago, which was developed in late 2010. And before that, early 2000, we have seen another information retrieval systems development, which is called Terrier, which was developed by University of Glasgow at Scotland. Now, all these were academic search engines. That is, there is no practical application, or of course, there are practical applications, but they were built from the point of view of doing research in the academia. The first known non-academic search engine was developed by Doug Cutting, which is called Lucene. Now, just to give you the information that I hope you have heard of the name Hadoop. So Hadoop is also developed by the same developer called Doug Cutting. So Hadoop was, after Lucene was developed, Doug Cutting developed this Hadoop system or Hadoop framework. So the advantage of Lucene over these academic retrieval systems are it is robust, very flexible, because all this was developed keeping in mind the research criteria only. But as Lucene was developed from the point of view of non-academic utility, it is very much flexible. It can be used for academic purposes. It can also be used for non-academic purposes as well. And it is very easy in Lucene to handle big data. Now, I hope you can understand the reason, because Hadoop or Hadoop distributed file system is actually very easy to be incorporated in Lucene. The reason is clear. They are both developed by the same person. Now, so far we have talked about Lucene, which is developed in Java. Now, PyLucene is basically a Python wrapper for Lucene. The goal of PyLucene is to allow Python researchers or Python users to use the Lucene's text indexing and text searching capabilities using Python programs or simple .py programs. Now, how this actually works? So basically, PyLucene embeds a Java virtual machine that is containing the Lucene into a Python process. Now, some part of the rest of this discussion of today might seem a little bit, hard to understand, but please give me some time. I'm sure I will be able to make you understand all the concepts. Now, What is a virtual machine? I hope you are having this question in your mind. You will be understanding the concept of virtual machine in a little bit. So basically, PyLucene embeds a Java virtual machine which is built within PyLucene to make a Python process to access this Java virtual machine. So basically, the Lucene will be inside in a virtual machine, which is basically a Java program. Lucene will be running inside this, okay? And using the Python program, we will be just interacting with the virtual machine. And we will be writing this Python program inside this virtual machine. I mean, although it is Java virtual machine, but the interaction will be so smooth, we will be, realizing or we will be having the impression that we are writing directly the codes to some Python packages. Because essentially, what we will be doing is we will be making an import to the corresponding package, which is called Lucene, after installing it. So this PyLucene, how it will be working? So it is basically built with a compiler called JCC. So those of you who had some background of C programming, I hope you have learned of you have heard of the name called GCC, which is called the Genome C compiler. This is JCC. JCC is basically a C++ code generator, which makes basically this interaction between Python and Java in a smooth way. And this JCC compiler should be installed before installing the PyLucene. And this JCC is actually, available together with the PyLucene resource or PyLucene programming package. So as you can understand, Lucene was first started in the early 2000. Now, after that, we can understand almost 20 years have passed, and with time, the application or the applicability and the vastness of data has also increased, right? So in early 2000, or say let's consider we are standing in say 2004. I hope you were at your school at that time. It was, we cannot actually imagine we will be holding a smartphone which is containing a 4 GB of RAM at our hand, because at that time having a desktop having say 256 MB of RAM is considered a huge, or a very high-end high-end system. So at that point, Lucene started its development, and with time, new modalities had come into the picture, new modalities of data, and the amount of data generation has also increased. So there were multiple versions that were available, with different updates of this Lucene. So presently, the latest version of Lucene is, I think, 9 point something, but we will be sticking to the version Lucene 8.8, and basically we will be considering the corresponding PyLucene version 8.8.1. So to install PyLucene, the prerequisites are we need the Java version 1.8. We need two other packages. One is Ant, which is basically a Java compiler. I mean, it's not actually only a compiler, it is basically a package which can actually make you I mean, given a Java program, it can make you an archive with the Java with the Java source. And IV basically is I mean, again, some generator which helps us to generate the correct version to run from a resource or from a source programming language, in this case Java. So we need to download PyLucene from this URL. And first, we should be starting with installing JCC. As I said, JCC is available in this PyLucene package. Now, after installing JCC, we should be installing the PyLucene following these 4 steps. First, we need to make an edit to the make file which is available. We should be making a tiny change is needed to be done in this make file, which will be available inside this JCC, inside this Python PyLucene resource that we have downloaded, where we need to change the corresponding Java installation path based on our system. Then we need to basically perform 3 operations: make install, and make test. Now I am sure you must be, I mean, already frustrated to see all these new terms here. What is this make file? What is this make? What is make install, make test? What are they? So make file is basically a simple text file where how to install a package is written. All the commands are written. So this is basically the very broad overview of a make file. Now these 3 commands are based on a Unix operating system. We can also install this command. I mean, to execute this command, we can also install the corresponding counterpart for Windows operating system as well. But as I said, there can be certain I mean, situations, or I mean, kind of weird situation if we execute the make install, or make test in the Windows operating system. Now, just to give you a very brief about how to install, how to make this install. So what we need is, we need to first download the Python, the PyLucene package from this URL. Now, just to show you, here, please click this, the first one. From here, you will be finding different versions. Note that I have said presently the latest version of Lucene is Lucene 9 something, but PyLucene is still running. The latest version is PyLucene 8.11. But we will be sticking to this 8.8.8. Okay, so what we need to do is, we need to download this src.tar.gz. Now, if we download this, we will be seeing, a package like this. So basically, it will be a zip file containing around less than 50 MB size, where these files will be there. As you can see, JCC is already there. So after entering into JCC, you need to install JCC. How you can install that, I'll be giving you the how-to regarding that in a separate IPYMB file, so that you can just run it from the notebook. After installing JCC, what you need to do is, you need to, as I said, we need to make an edit into this make file. Specifically, the edit that we need to do is, we need to change the path of your Java installation here. So it can be different based on the Java version that you are using. Note that for running PyLucene, we should be having Java 8 or Java 1.8, which is basically kind of same. We should not be using Java 11, which is the present, I think the recent version or the latest version, because there are certain issues with using PyLucene on Java 11, the latest version. So here we just need to make this change based on your operating system. This is the path where my Java installation has been done. So that's why I have mentioned this. Okay. And after that, as I have mentioned, we need to perform this command. So basically, how to handle these commands or what to do on, giving this make command is basically written in this make file. So we just need to open the terminal and we just need to perform, or we just need to type in this make command, and it will be installing the PyLucene at our end. Note that this will be needing around 15 to 20 minutes. And sometimes if you face permission denied error based on your operating system or the way you have installed your operating system, it can actually give you a permission denied error. In that case, you need to give it a sudo permission. Now, those of you who are using a Unix operating system, I hope you know what is a sudo. It is basically giving, basically to perform some super user operation, we should be giving this sudo before this command, actual command. So basically, we need to type in sudo space make. Now, after that, this command will be basically setting up the configuration based on your operating system, the version that you are using, the version of Java that you are using, the version of Ant you are using, the version of IISER you are using. All those information will be basically configured together with the installation procedure. Now, make will not be actually installing the PyLucene at your system. Now, after that, make install is the command which will be actually making the installation. Now, this make install can actually take more than half an hour, or based on the processor speed, it can take around 1 hour as well. But I hope it would, considering 2022, the present year, I hope you are not using, I hope you are using significant processor speed, with the system with a significant processor speed, not like myself, which, I had an operating, I actually have a desktop which is still running a Pentium 4 processor. There it actually took around, more than half an hour. So after that, after this command, it will be basically, the PyLucene will be installed in your system. Then make test, make space test, it will be basically giving us the output, so from which we will be able to understand whether the installation of PyLucene was successful or not. So if it is not success, if it is not a success, then it will be giving us some certain errors. Okay, so how actually this command should be executed? Where should we be? From which present working directory should we be performing this search? I'll be giving you basically a IPYMB file which will be containing all the information for you guys. So from sitting inside your Jupyter notebook, you will be able to install PyLucene. So these are the procedure, and this is some small codes to check the installation as well, whether PyLucene has been successfully installed or not.